Hello students. So today I will see the new topic, that is CVT. For that purpose, I want to share my screen. So first I want to show you introduction of CVT. So here today automobile use either a conventional manual or automatic transmission with multiple planetary gear sets that use clutches to achieve discrete gear ratios. Means we use manual system, then automatic transmission system is also there, and in that planetary gears, the continuously variable transmission replaces the discrete gear ratios with infinitely adjustable gearing through one of several basic CVT design. A continuously variable transmission is a transmission that can change seamlessly through an infinite number of effective gear ratios between maximum and minimum values. The flexibility of a CVT allows the input shaft to maintain a constant angular velocity. Overview of a CVT, that is it varies the transmission ratio continuously, means that ratios while transmission of speed or power from one shaft to another shaft, this is continuously changing, and due to that transmission ratios also changes, shifts automatically with an infinite number of ratios. As it changes continuously, so infinite number of transmission ratios are available. Seamless power delivery then constantly changes its gear ratio to optimize engine efficiency. Okay, so as the transmission ratio changes according to the requirement, so engine efficiency is also good. It allows the engine to revolve almost immediately to deliver maximum torque. Basics of transmission. If we see this diagram, this is engine, this is clutch, then this is transmission, this is joint, which is used for drive shaft to transmission system, that is U joint is used, differential gearbox, and this is the rear wheel. If we see, the job of transmission is to change the speed ratio between the engine and the wheel of an automobile. The transmission uses a range of gears to make more effective use of the engine torque as driving condition changes. There are three types of transmission, that is manual transmission, automatic transmission, and semi-automatic transmission. Okay, and if we see the problems with manual and automatic transmission, the traffic condition has become annoying in our big cities, so fuel consumption is very high. In such a case, will automatic transmission makes sense to the Indian customer, but conventional automatics always consume slightly more fuel than manual transmission and the lack of sophisticated automatics. Components of CVT. First is a variable input driving pulley. Okay, a variable input driving pulley. Then second is an output driven pulley. Then third is a metal belt, or it is also rollers are also used in place of metal belt. Then sensors and microprocessors are there. If we see this right hand side diagram, this is the pulley, which is variable, and output driven pulleys. Okay, a metal belt is used. See here, this is the belt, and see here, this is the adjustable pulley. So that is arrow, which is in outward direction. It gives the space for this belt, and this belt shifts downward direction, or it comes closer towards the shaft, and so the diameter or the radius in this case is less when the pulley moves in outward direction. When this pulley moves in outward direction, then this green color pulley comes in inward direction, and due to that the diameter of this pulley gets increases. So when this orange color pulley moves outward, then this green color pulley moves in inward direction. In this way, the diameter gets adjusted, and in this case, the diameter of this orange color pulley is less than diameter of this green color pulley. And in this way, if this is the input shaft, then and this is the output shaft, then from small diameter towards the greater diameter, then speed is limited or the speed decreases. In opposite case, when the orange color pulley comes closer, in that case the green color pulley goes in outward direction. So in this case, the diameter which is less at this pulley, that is green color pulley, and diameter is greater in orange color pulley. So in this way, the if we consider again, this is the input shaft, then diameter of input shaft is, or diameter of input pulley is maximum than diameter of this green color pulley. And in this way, the maximum rotation transmitted from maximum diameter towards the minimum diameter. Working principle: a pair of variable diameter pulley, each shaped like a pair of opposing cones with a metal belt or chain running between them. One pulley is connected to the engine or input shaft, from where the power is coming, and the other to the drive wheels or output shaft. As the pulley halves come closer together, the belt is forced to ride higher on the pulley, means diameter gets increases. We already discussed this point. Effectively, changing the diameter of the pulley. Where is the transmission ratio? If we see the how CVT works, okay, all these diagrams are same as we discussed. In this case, on the left pulley, which comes in the outward direction, and on the right hand side pulley, which comes closer. And in second diagram, the left side pulley comes closer. In that case, the outside pulley, or on right hand side pulley, goes in outward direction. So actual view of the diagram is as here at the bottom in left side. Okay, and this is again the actual diagram. Types of CVT: metal push belt CVT, then toroidal drive CVT, variable diameter pulley belt CVT, hydrostatic CVT, magnetic CVT. These are the different types of CVT. This is the low gear, this is drive pulley, this is driven pulley, this is high gear, this is driven pulley, and this is drive pulley, and this is driven pulley. Okay, low gear means diameter is less, driven, and high gear means diameter is more in that case. Simulation of CVT. Okay, actually simulation is not available currently, but the push belt, this belt transmits the power between two conical pulleys or sheaves, one fixed and one movable. A sensor reads the engine output and then electronically increases or decreases the distance between pulley and thus the tension of the drive belt. Toroidal traction drive CVT, it uses rollers to transmit the torque between the input disc and output disc. If you see this diagram, discs are used. A viscous fluid transmits the torque between rollers and disc. Rollers and disc never touches. The angle of roller changes relative to shaft position, resulting in a change in gear ratio. The change in angle by a roller must be mirrored by opposing roller. If we see this toroidal CVT, okay, if we see this is the faster and this is the slower, and this is the rotation. Okay, then as this is the faster, then in the upward diagram, in upward condition, this is the slower condition. And in second diagram, as the speed is same or equal, in this case the pulleys becomes vertical, and in this case it is also transmitting in same speed. In this case, the pulleys, which is represented with yellow color, moves in downward direction or inclination in downward direction, and as the speed is slow, and here the speed is fast. Advantages of a CVT: it decreases the engine fatigue, infinite number of gear ratios, maintaining the engine in its optimum power range, more mechanically efficient than automatic transmissions, great fuel efficiency than both manual and automatic transmissions, fuel savings of more than 17% and smooth, responsive, and quiet to drive. These are the advantages. Okay, as we use CVT, then engine fatigue gets decreases because it automatically adjusted, and due to that the engine fatigue gets decreases. And infinite number of gear ratios, as it automatically changes its or shifts on the pulley, and due to that one on the left side if the input shaft is there, and on the right side if output shaft is there. On input side if the diameter is less, then on output shaft output side the diameter is greater. In this way infinite number of gear ratios are possible, and opposite way if we increase the diameter on the left side or input shaft, then the diameter on the output shaft is also decreases. More mechanically efficient than automatic transmission, greater fuel efficiency we are getting, and smooth, responsive, and quiet to drive. CVTs versus manual transmission, theoretical comparison under ideal conditions. This is 1991 Fiat, you know, that comparison. So mass is 1250 kilogram, torque is 101.2 Newton meter. This is on y-axis vehicle velocity, that is kilometers per hour in both the cases, that is manual transmission and CVT. Engine speed is there on the x-axis in both the cases. If we see manual transmission, then this dark line represents our manual transmission system, and this dark line on this second diagram shows the CVT. So as engine speed increases, the vehicle velocity initially increases, then again it's stable, and in this case engine speed is again decreases, again vehicle velocity increases, again in stable condition, again increases, again in stable condition, again increases, stable condition, increases. So a lot of changes are there in manual transmission. But in case of CVT, as engine speed is increases, vehicle velocity continuously increases. After achieving one value, then it drastically increases the velocity of the vehicle. Okay, so if we see 0 to 100 kilometers per hour, so manual transmission, that is 11.9 seconds, and in CVT 8.8 seconds it achieves. Okay, so CVT proved 35% more efficient than manual transmission. With same car and engine, the CVT takes only 75% of the time to accelerate to 100 kilometers per hour compared to the manual transmission. If we see the drawbacks, then limited torque capacity when compared to manual transmission. Okay, additional gear train required for reverse condition, larger and more costly than manual transmission, unwillingness to discard billions of dollars in development in manual transmission and automatic transmissions. So if we see the drawbacks in detail, then torque capacity, okay, it is limited torque is available in this case, because according to the size of the pulley, or when the pulley sizes are fixed in maximum condition, so not that is this is the limited condition. If we want to move beyond that limit, then it is not possible. So additional gear train required for reverse condition. If we want to reverse, then we required one more gear, and in that case the overall cost is again increases, larger and more costly than manual transmission, unwillingness to discard billions of dollars in development. Again, if we see the uses, many small tractors for home and garden use have simple rubber belt CVTs. For example, the John Deere greater line of smaller utility vehicles use a belt with conical pulley system. They can deliver an abundance of power and can reach speed of 30 to 32 miles per hour, that is 48 to 51 kilometers per hour, all without need for a clutch or shifting gears. Nearly all snowmobiles, old and new, and motor scooter uses CVTs. This techniques uses the rubber belt or variable pulley variety. In various ATV or CVT is most widely used due to better fuel economy. If we see the future of CVT, the IC engine is nearly both perfection and obsolescence. Advancements in fuel economy and emissions have effectively stalled. CVTs could potentially allow IC vehicles to meet the first wave of new fuel regulations, and cost will be reduced further and performance will continue to increase. Ultimately, it will give CVTs a solid foundation in the world's automotive infrastructure. So CVT is very good technique in overall. So this is very useful. If we use, then lot of transmission ratios are available for transmitting the power. Losses which are occur in a regular or manual transmission system, it gets avoided in this case. So in this way, we finish this lecture related to CVT. So we stop here. Thank you.